Hello, I'm Ghazal Shivani, master student from Iran University of Science and Technology. Today, I'm going to talk about one of my favorite interests, game production using artificial intelligence, which I'm gonna present it to you in purpose of GameGAN reimplementation with a gaming perspective. Let's first talk about where the problem arises. GameGAN is a generative model that learns to visually imitate the desired game by ingesting screenplay and keyboard actions during training. Given a cue pressed by the agent, GameGAN renders the next screen using a carefully designed generative adversarial network. GameGAN had many imperfections to be a game engine. For instance, it can disentangle only dynamic and static components, while MC-GAN has so many complicated classes for accepting features from games and make new games that come from its elegant and strange gaming perspective. There are also many other drawbacks in game generation using AI, such as being a time-consuming process and etc., encouraged us to develop MC-GAN as the next generation of game engines using AI for the full automation process. For now, let's take a quick look at GameGAN. As you can see, it has three main modules. The dynamic engine that maintains the internal state variable in which we currently updated. It also holds a stochastic variable to understand and predict the unpredicted events in stochastic environments. For environments that require long-term consistency, an external memory module is used to remember what the model has generated so far. Long-term consistency ensures returning to the same state that generates the same events. Finally, the rendering engine is used to decode the output image at each time instance. All modules are neural networks and trained end-to-end. MC-GAN has been a significant improvement over GameGAN. It emerges with impressive strength, the ability to explore 4 deep layers of the game to classify static and dynamic game components. For instance, MC-GAN is capable of distinguishing and categorizing various types of booleans, while GameGAN presumes all of them identical. As a result, MC-GAN uses layers in depth 4 down when producing a new game and merges them, which compared to GameGAN generates more precise and detailed games. Another advantageous aspect of MC-GAN is the ability to add new levels to the game, whereas the GameGAN can only produce new games, not noticing this is already the same game it has been trained on before. As mentioned, GameGAN is an innovative model but lacks a gaming perspective. To overcome that, we propose a new concept driven out of GameGAN named inner model. Actually, the inner model is the result of redesigning GameGAN as a combination of memory module and dynamic engine. The internal model is the core concept and the base of our model. It uses the same algorithm for the dynamics engine and memory model as in the GameGAN and outputs the same data layer used in the rendering engine. We then create a model consisting 3 parts: Multi-GAN analyzer, data unifier, and rendering engine. In Multi-GAN analyzer, we use an inner model for each Boolean agent, player agent, and train agent to work simultaneously but separately. This ensures multi-layer classification of static and dynamic data. The complexity created in the Multi-GAN analyzer makes it difficult to work with the data if it is not handled. The data unifier aims to unify all the data generated in different classes in the Multi-GAN analyzer to reduce this complexity and make the data ready for visualization by rendering engine. It is also not without merit to mention that all interactions between various agents are done via backpropagation through this module. However, at last we have rendering engine. Exactly like GameGAN, it is responsible for rendering simulated images using last base of dynamic engine and memory module generated in the data unifier and decode output image at each time instance. Let's move ahead. As mentioned, MC-GAN uses one single complex model that will be trained once per game. It can investigate each game individually and categorize it. For instance, in Super Mario game with the MC-GAN, there is no need to create another model and train it to create the next levels, since we already trained one complete model for it. But as an example to visualize the mixing capability of MC-GAN, we brought this figure representing the generated games with swapping the player agent's characters. Although this complexity reduction saves plenty of time and resources and can be a great platform to start a new generation of game engines, there are still too many imperfections in MC-GAN. Hope you enjoy our presentation. Thank you for your attention.